let us start. In last class, I was discussing with you about the Legendre polynomial, and these topics you will not get extra time to prepare. So you have to prepare it in the class itself, and just before few days you have to give some revision because there will be so many other topics for you जिसको आपको prepare करना पड़ेगा. Okay. So the Legendre polynomial, I told you about the basic structure of the polynomial, and I think I told you about some properties, some special values also. What was, and the parity relation also. One formula was left that I wanted to tell you, and that formula is known as uh, Rodrigues formula. Okay, Rodrigues formula. So this formula gives us a method to calculate different polynomials, and the value of the polynomial is given by 1 upon 2 to the power n factorial, and d by dx to the power n, and x square minus 1 to the power n, x square minus 1 to the power n. So this formula is known as Rodrigues formula, and you can see clearly that from this formula we can derive different polynomials. For example, if I want to derive p0x, so please see this, n is equal to 0, I have substituted, this will become 1, this will become 1, power 0 means this will become 1, and this will also become 1, so p01 will become 1, correct? And we know that this is the zero Legendre polynomial. Now what about p1x is equal to, so if you write p1x, it will become 1 upon 2 to the power 1 into 1 factorial d by dx and x square minus 1. So if you write this, it will become x. So p1x is equal to x. So see, we have derived two polynomials, correct? Okay. And what about the p2x? अपने आप निकालना है जरा. Calculate the value of p2x by yourself. It will come out to be half 3x square minus 1. See this?
Yes. Yeah.
Okay. So in this way, this Rodrigues formula can give you any of the Legendre's polynomial. Okay. Now I told you to remember three Legendre polynomial. What is the reason? Some property is asked, and if you don't know the property, so you can apply that, you can put that value and check whether it is correct. I will tell you what do I mean by this. For example, there are so many recurrence relations of this, and I want to know, I will give you randomly a recurrence relation, and I want to know which one of the recurrence relation is correct. Okay. So suppose I write one recurrence relation 2n plus 1x and pnx is equal to n plus 1 and pn plus 1 x plus npn minus 1 plus npn minus 1. Okay, this is the relation, and the value of n is equal to 1 2 3 dash dash dash. I want to know that if so many such options are given, can you tell which one of the relation is correct? what you will do? It is so difficult to derive if you remember, but if you remember few terms, for example, I can put n is equal to 1 here, and what I will get, by elimination method we can see which one of them is correct. So suppose n is equal to 1, I put क्या आ जाएगा बताओ, 3x p1x is equal to, n is equal to 1, 2 p2x plus 1 p0x. ये आ जाएगा. This relation will come. I have substituted n is equal to 1 in the above relation. So you will get this relation. Yes or no?
Yes, sir.
And now check this. This will become 3x p1x is x is equal to 2. What is p2x? Half of 3x square minus 1 and plus 1. Both are equal or not? So see, this 3x square will become 3x square. So that means if there are other options which are not following that, so at least they are not true. You can reject them and the correct option you can reach. So please remember, write it as a note, that if in any question you don't know that property or you don't know that question, check it with, check the polynomials with p0, p1 and p2 like I checked in the previous question. सबको बात समझ आ गई? And the next I want to ask from you, I want to ask from you that tell me if this is correct. So don't
Okay.
forget to check this. अबे ये question 5 marks का सीधा आता है. So don't forget to check. और 3.5 या 5 marks में किसी में आता है question. So don't forget to check it. Even if you don't know, you have P0, P1 and P2, so you can check if that is following. So let me give you another one for you and tell me if this is correct. This relation is correct or not. 1 minus x square p n double dash x minus 2x p n dash x and plus n plus 1 p n x is equal to 0. Check this and tell me if this relation is correct. And you don't know the relation ना, आपने suppose पहले देखा हुआ नहीं है, you have not seen this. So what you will do, कैसे बताया मैंने?
N equals to 1.
I can take anything. Suppose I take n is equal to 1 or n is equal to 2. So suppose you remember here only one value of n is there. So suppose let me take p1. What is p1?
X.
X.
So it will become 1 minus x square p1 double dash. What it will give?
0.
0.
0.
Minus 2x p1 dash
1.
1.
1 plus 1 plus 1 into x is equal to 0. So this term is 0. So minus 2x plus 2x is equal to 0. This is absolutely correct. बात समझ में आई ना? So checking by substitution. You understood this point or not?
Yes, sir.
Yes, sir.
Sir.
Now I wanted to tell you that I have, what is the name of P and X? Tell me. What is the name of P and X?
Legend is Pauline.
Legendre's polynomial. Very good. And I wanted to tell you the equation which I wrote here is Legendre differential equation. Okay, so let me write it again in the form which you know. 1 minus x square dy by dx minus 2x dy by dx plus n plus 1 y is equal to 0. You have seen this equation before? This is the famous.
It's d square y by
The
dx.
first term is d square y by dx.
Thank you. So this equation is Legendre differential equation. And what is its solution? How to solve this equation? Above equation is solved using infinite series method. आपने ग्रेजुएशन में पढ़ा होगा ये मेथड, infinite series method. We solve it using infinite series method. So what is the solution? Tell me.
So y equal to Pn of x.
Y is equal to
Pn of x.
y is equal to
Pn of x.
Pn of x. भाई आप लोग इधर देख नहीं रहे हो, यहाँ पे देखो जरा ध्यान से. सॉल्यूशन की जगह क्या लिखा हुआ है? What is written in the place of solution? So this y is equal to Pn of x is a solution of our equation. So obviously the solution of Legendre differential equation is known as Legendre polynomial. The solution can also be some linear combination of this, because you know this is right hand side is 0, so this is homogeneous equation. So suppose the solution is some c1y1 plus c2y2. So this y1 also follows the equation and y2 also follows the equation, and the linear combination also follows the equation. So all of the three will follow the equation. This is the Legendre's differential equation. And the next question. So please see. Now I want to know I want to calculate the value of Pn dash 1. This value I want to calculate, and you can see that you
Sir,
have
Sir, I was saying कि जो रिकरेंस रिलेशन के लिए हमने P1 ऐसे वैल्यूज पुट करके जो देखा, तो सर P1 के लिए वो वैलिड है, तो ये जरूरी कैसे हुआ कि इट इज वैलिड फॉर P0 एंड अदर वैल्यू?
नो आई एम नॉट सेइंग. इसीलिए मैंने बोला कि गलत होना पक्का सबूत है कि वो सॉल्यूशन नहीं है, सही होना पक्का सबूत नहीं है. तो जैसे आपके पास 4 ऑप्शन है और अगर 3 गलत होके निकल गए तो जो सही है वो अपने आप सही हो जाएगा. ओके.
ओके.
So I want to know this P1 Pn dash 1. So this will become write the equation again. So it will become 1 minus x square Pn double dash x minus 2x Pn dash x plus n plus 1 Pn x is equal to 0, and you can see we want Pn dash 1, correct? So let us put x is equal to 1. So what will happen? The first term will become 0 and it will become minus 2 into 1 into Pn dash 1, correct? And plus n plus 1 Pn 0. Sorry, Pn1 is equal to 0. So Pn dash 1 will be equal to n plus 1 by 2, because Pn 1 is always 1. Pn1 is always 1. Tell me if that is okay. So Pn dash 1 is this value. Suppose I want to know the value of the double derivative. Okay, suppose I want to know the value of this. So what will happen? I will write the value Pn double dash 1 is equal to question mark. Now you can see, अगर आपने इसको डायरेक्ट पुट कर दिया तो ये तो टर्म ही गायब हो जा रहा था ना. This term was not there, but I want Pn double dash 1. So for this type of question, the trick is that first of all take a derivative so that you will get two terms. So first derivative is 1 minus x square Pn triple dash x, and the second derivative is plus Pn double dash x into minus 2x. Okay, and then what about this? Minus 2 x Pn double dash x plus Pn dash x, correct? And what about this? Plus n plus 1 Pn dash x is equal to 0. Now if I put x is equal to 1 now, what will happen? This term will be gone, and then we will get Pn double dash of 1, which I wanted. So this will give me minus 2 and minus 2 into 1 into Pn double dash 1 plus Pn dash 1, which I have already calculated, and plus n plus 1 Pn dash 1 is equal to 0. देखो जरा, tell me the value of, calculate it first properly. Calculate this quickly and tell me what is the value of this Pn double dash 1 is equal to, tell me. And you already know what is value of Pn dash 1. You have calculated in previous question that.
Sir, n square plus n minus 1 by 2
N square
plus n minus 1 by 2.
Anybody else?
N. So n into n plus 1 over 8, that's whole into n plus 1 into n minus 2.
N into
Yes,
n
sir.
plus 1 over 8.
No, sir. N square into n plus 1 whole square.
No, sir. N into So by 8 is coming.
n into n plus over 8 and then n plus 1 minus 2, na?
Yes, sir.
Yes, sir. Plus 1 minus 2.
So this is Pn double dash 1. So these type of small questions are asked which you can solve quickly, not the very long calculations. Okay. Now a question they ask, since the Legendre polynomial, you see this belongs to different powers of x. For example, the p0 x is 1, so it is in a way x to the power 0. Then p1x is x, so it is like x to the power 1, and p2x is 1 by 2 3x square minus 1, so it is power 2. This is power 2. Now in this way, this means we can write any polynomial using Legendre polynomial. So please write this as, this is very important. 2 times questions have been asked in NET exam on this.
Sir, one minor intervention. Say the last solution, sir, it can be further simplified. Is it necessary, sir?
हाँ, it's okay. If क्या बहुत ही छोटा हो जा रहा है तो बता दो.
नहीं सर, बस वो आ रहा है n into n plus 1 into n plus 2 into n minus 1 upon 8.
हाँ ठीक है, ठीक है. मतलब क्या आ रहा है एक बार बता दो. n
n into n plus 1 into n plus 2 into n minus 1 upon 8 whole upon 8.
अच्छा ठीक है, ये तो ज्यादा कॉम्पैक्ट लग रहा है. ठीक है.
हाँ,
एक बार जरा आप लोग बाकी लोग भी देखना इफ दिस इज करेक्ट. हाँ,
थैंक यू सर.
इमोन, आपने एक बार दोबारा से जरा क्विकली देखना कि कोई गलती तो नहीं है इसमें. ठीक है,
ठीक सर. ओके, थैंक यू सर.
करेक्ट है ना? वेरी गुड. तो दिस इज मोर कॉम्पैक्ट फॉर्म and this can become n square minus 1, na? Iman?
Yes sir, it will become n square minus 1. Yes,
but
n into n square minus 1 into n plus 2. Yes sir.
बस ठीक है, it's okay, very good. अब प्लीज सी ये जरा फोकस करो, ये जो बता रहा हूं मैं, what I am trying to tell you, कि you have polynomials representing different powers of x in the form of Legendre polynomial. Is this correct, na? So that's why I am giving you here that any polynomial can be. Acha, by the way, I told you the reference of this chapter, na? That is Erskine. I am following Erskine for this chapter. Okay. So any polynomial can be written in form of Legendre's polynomial. Legendre's polynomial. So इसका मतलब ये हुआ कि जैसे आपको किसी को कहना है कि भाई आपके पास I am speaking too much Hindi. Okay, suppose you want to so this is clear. Any polynomial can be written in the form of Legendre polynomial. Any polynomial, quadratic, linear, cubic, any polynomial. And I will give you an example. Before that, suppose I want to say somebody 1 lakh rupees. 1 lakh rupees. So I can just write P0x lakh rupees. क्यों भाई? Yes or no? In the code,
Yes.
because these two things are same. I mean, this was just to tell you. Now please see this, the question, a previous year question, just to hint you what type of, and so many questions already I told you that all they belong to previous year. One question that I want to tell you, this is fx is equal to ax square plus bx plus c. This is quadratic. Write it in form of Legendre polynomial. So this was objective question. 4 options were given. Now please see, it is so easy. Fx is equal to a. Now take x square from here. What you will get? X square is equal to what you will get? 2 times p2x, yes, plus 1 by 3. Am I correct? So it will become 2 times p2x plus 1 by 3. किसी को कोई प्रॉब्लम होगी तो बताना. फिर प्लस b टाइम्स x को क्या लिख दूं? p1x, correct? And what about c? Tell me.
P0x.
p0x. So you have written fx in the form of Legendre polynomial, summation of that. So first thing is p2. So what is coefficient of p2? Tell me. 2 by 3a p2. Correct? Yes or no?
Yes, sir.
Yes.
Then comes p1. What is coefficient of p1? b. And then comes p0. What is coefficient of p0? c plus a by 3. p0. So this is 5 mark question. Yeah, or I don't remember. 3.5 mark question, net question. This is how we have written the function in the form of Legendre polynomial. Please see this. And if there is any doubt, please ask. Feel free to ask if there is any doubt. Hello.
Venkat sir.
Venkat. Tell Venkat. What?
That in a f of x, the answer c plus a by 3. How? I couldn't understand.
p0, see? If it is only c, you can write c into p0 or not?
Yes, sir, yes.
How you can write? Tell quickly. How you can write? Bolo bhai, Venkat. C can be written as c into 1.
Yes, sir. C
So-
into 1.
So
C not 1.
c into p0x, because p0x is 1. So that's why I wrote here c into p0. Now please see, 1 is written here. So 1 can also be written as, yes, p0x. Correct? Got it, Venkat?
Yes, sir. Thank you.
Okay. Anybody else want to ask anything? So please remember this, that you may have to write an algebraic equation in the form of a Legendre equation, as I have written here. Now sometimes directly, not recently but before, they have asked on orthogonality. Orthogonality. Orthogonality relation of Legendre polynomials, and that is given by integral -1 to 1. Why -1 to 1? Anybody can tell? Why integral?
Because lies between minus
Because x lies between -1 to 1, and this is because x was equal to cos of theta. That
Cos theta.
I told you in the derivation. So this into Pn x into pmx dx is equal to 2 by 2n plus 1 Kronecker delta nm. This relation is known as orthogonality relation, and you know the meaning of this Kronecker delta nm. It is equal to 0 if n is not equal to m, and it is equal to 1 when n is equal to m, and this is known as Kronecker delta. Kronecker delta. Just to represent. Correct? So now please see, the orthogonality relation can solve so many integrations, so many tough integrations. For example, suppose you see -1 to 1, and I have told you the P3 or P4. Which one I have told you? The highest one?
Both sir, P4.
P4. कोई बता दो जरा, आप भी बता दो. What is your name?
Anush sir.
अनुज बता देना जरा P4 की वैल्यू.
1/8.
1/8.
35x to the power 4
Yes.
minus 30x square plus 3.
Very good. Plus 3. So this is the value of P4, and if I write square of this dx, its value is so tough. Can you see? If I have to open it and then integrate it, na? But I can write this as this equation as equal to -1 to 1 Pn square dx. That means n is equal to m, and the answer is equal to 2 times 2n plus 1. So what is the order of polynomial? It was P
P4.
P4x. It was P4x. So what is the answer? 2 by 2 into 4 plus 1, which is equal to 2 by 9. Can you see? Because when n is equal to m, this Kronecker delta will become 1, and the value will become 2 by 2n plus 1. So I have directly used that. So the value of this integral is this 2 by 9. Correct?
Yes.
So now the thing that I told you to substitute the value to write the algebraic form. So there is a possibility of another method from here. See, I told you that we can write an algebraic equation in the form of Legendre polynomial. What does that mean? That means fx can be written as some summation of Legendre polynomial. ना यही तो बोला था मैंने. Where n starts from 0 to infinity. जितने भी terms आ जाएं, 1, 2, 3, 4 or infinite terms. You agree with this?
Yes.
So if fx is given, we can directly calculate the value of cn, the coefficients. So please see this. You know the orthogonality relation. So what I can do is I can multiply integral -1 to 1 fx into pnx dx, and that will become summation n is equal to 0 to infinity integral -1 to 1 cn pn x square and dx. देखो ये समझ आता है सबको? Multiplying both sides by pnx and integrating in the limit. Correct?
Yes.
And you see this this cn, if you take the different values of this, what you will get? What is the value of pn square? So it will become cn, and pn square is 2 by 2n plus 1. and the value of Cn will become 2n plus 1 by 2 integration minus 1 to 1 fx pnx and dx. This will give you the value of different coefficients. Okay, so suppose I give you a function, so using this you can calculate this coefficient and you can write the series for the function. So like I give you an example, जो क्वेश्चन मैंने अभी कराया था, आप इसको होमवर्क है, उसके कोफिशिएंट्स इससे निकालना. Like you see, fx was what? ax square plus bx plus c. This is the value of fx. Put it here. Then calculate c0, c1, c2 and use orthogonality relation quickly to calculate the value. So calculate Cn for this. And once you get Cn, then you can just write the series.
How minimum 3 values you told me, sir? Find
No.
Cn.
No. Here you calculate the general value Cn. And then you will see that all other values will become 0 because of this relation minus 1 to 1 pnx dx. Okay, so you can cross check what the coefficient we calculated. You can cross check from here. See what is the fx now. Fx is what? c0 p0x. So c0 will be the coefficient of p0 plus c1 p1x plus c2 p2x, like dash dash dash. And you know the three coefficients I calculated for p0, p1, p2, you can calculate it from here and all other coefficients will become 0. Are you able to understand it?
Yes, sir.
Yes.
So two methods I told you. One is from this orthogonality relation and another one is directly writing. So isko solve karna and then I will take the topic further. Okay, but यहीं पे करने की कोशिश करो, सारी चीजें यहीं समझ लो. If there is any doubt, please ask. Okay, so let us meet for next class. Okay then, thank you. I was discussing with you in last class. I told you about the Legendre's polynomial and we discussed lot of things. And now the same pattern we will follow for other polynomials and we will see what are the important points and उनको बिल्कुल short में कैसे manage करना है. Okay, so the second one is the Bessel's polynomial and Bessel's differential equation. Okay, so Bessel's differential equation and Bessel's polynomial. Bessel's polynomial, correct? Bessel's differential equation and Bessel's polynomial. So like I gave you the introduction in the case of Legendre polynomial. So let me tell you that where it appears. Let us write that so that you will know the importance of this equation. So where it appears, let me write here. The first point is when we solve wave equation, so what is wave equation? It is a partial differential equation. So when we solve wave equation so we solved in Cartesian, but suppose we have solved in cylindrical coordinates. Cylindrical coordinates. So suppose the wave equation is solved in cylindrical coordinates. For example, suppose a wave is traveling in a nanotube, which is a cylindrical tube. So then what will happen? We get Bessel's differential equation as radial part. So in wave equation there will be three parts. In wave equation there will be three parts. First part will be the radial part, second will be the theta part, and third one will be the phi part. So the radial part hoga, that will give you the Bessel's differential equation. Second point, the WKB approximation, in quantum mechanics, WKB approximation in quantum mechanics involves Bessel's function. Okay. The third one, suppose you solve the Schrodinger wave equation in quantum mechanics. So that's why this special function chapter is very, very important for quantum mechanics. So suppose you solve the Schrodinger equation, you solve it for harmonic oscillator, you solve it for the hydrogen atom problem. But suppose you solve it for a spherical potential, which is actually done in nuclear physics. So when you solve it in that, so the third one is the spherically symmetric potential. The spherically symmetric potential. The spherically symmetric potential in Schrodinger equation. The spherically symmetric potential in Schrodinger equation is solved using Bessel's function. So the spherically symmetric potential in Schrodinger equation is solved using Bessel's function. And the fourth one is, this is just to tell you the importance of Bessel function. Nuclear scattering problem. Nuclear scattering problem involves Bessel's function. So from objective point of view, objective question point of view, only limited things can be done. Otherwise it becomes, very, very difficult to solve. So that cannot be given in your, objective question. So we will focus on that. So you have understood this. So that's why I'm telling you in general, the special functions like Legendre, Bessel, Hermite and Laguerre, these polynomials and these differential equations are very, very important as far as quantum mechanics is involved, because while solving the quantum mechanical problems for different potentials, you solve it using variable separable techniques, and when you convert using variable separable technique, when you convert those equations into ordinary differential equations, one or other ordinary differential equation becomes Legendre, Bessel, Hermite or Legendre. Correct? So this introduction is clear to everybody?
Yes, sir.
So can I erase this?
Yes, sir.
Okay. So yes.
Sir, wait for 2 minutes.
Okay. So this Bessel's differential equation, if I would have solved the wave equation in cylindrical coordinates, then one of the parts that becomes ordinary differential equation would have been Bessel's differential equation.
Done, sir.
Okay. So now see how the Bessel's differential equation looks like. This is also one of the questions that kind of they ask that which one of the following is Bessel's. Directly nahi, thoda indirectly. But if you would have known what is the Bessel's differential equation, you would have done it. So this is the Bessel's differential equation. This is the Bessel's differential equation, and you know this is a second order differential equation. All of the special differential equations are second order ordinary differential equation and also homogeneous. Homogeneous differential equation, because you know right hand side part is 0, so its solution will be like this. You know the solution, how to write the solution of this. Two solutions will exist and the solution will be the linear combination of the two. So y1 will also follow this equation, y2 will also follow this equation, and this linear combination will also follow this equation. Correct? So now when I write the solution, please understand the Bessel's polynomial is represented by this, the nth order Bessel's polynomial. So this is nth order Bessel's polynomial. Correct? So nth order Bessel polynomial is given by this. So the solution of that equation is given by some jnx plus c1 j1x plus c2 j minus nx. c1 jnx plus c2 j minus nx. This is the where Jn is the Bessel polynomial, nth order. So this linear combination is the solution of this differential equation. And like I told you, the value of Legendre polynomial Pn, I would also like that we should know. So this thing you should remember. The Bessel's differential equation we should remember. And now what I am going to tell you is the series solution. So when we solve this equation using the series, I told you ना कि हम इसको क्या करते हैं, we consider that the solution is in the form of infinite series and then we solve it. So after that the solution is given by y is equal to j and x is given by, so this j and x, I mean the Bessel polynomial is given by, इसको जरा नोट कर लो, ये सबको याद रहना चाहिए. और याद का मतलब ये है कि अगर आपने अच्छे से देखा भी हुआ है तो ऑप्शंस में से आप पहचान लोगे, यू विल रिकॉग्नाइज इट. तो समेशन r is equal to 0 to infinity, this is the series solution, minus 1 to the power n and x by 2 to the power n plus 2r and 1 upon r factorial n plus r factorial. So this is the series solution of the polynomial, and let me tell you what is the meaning of this. And this is, knowing this is a previous year net question, knowing this is another previous year net question, and the knowledge of J0 J1 is another previous year question. So these type of elementary questions. So first question is just to recognize that this is the
सर ये लास्ट सॉल्यूशन में -1 to the power r आएगा ना?
-1 to the power n
Okay.
x by 2 to the power n plus 2r 1 upon r factorial n plus r factorial. अभी मैं बताता हूँ कि कैसे इसको लिखते हैं. Suppose from this I want to write J0. So all of the polynomials will be actually infinite series, unlike the Legendre. Legendre में वो infinite series नहीं होती थी, but here all of the polynomials will be infinite series. So this will be given by summation r is equal to 0 to infinity minus 1 to the power 0 x by 2r to the power 0 plus 2r and 1 upon r factorial into r factorial. Please see this.
Here
It's
2r.
x by 2, sir.
2 नहीं है sir.
X by 2, sorry. X by 2. So what will be the value of J0 now? So the first term when r is equal to 0 will be equal to 1. Yes. Yeah, this is sorry, please correct this. This is -1 to the power r. -1 to the power r. This will change the sign. Correct this please. -1 to the power r. So the first term will become 1, and what is the second term when r is equal to 1? So it will be, this will give minus, and r is equal to 1. So it will become x by 2, yes, square. Then r becomes 3, again it will become minus 1 upon, sorry, r becomes 2, no? This
Yes,
is
sir.
0, this is 1, this is 2. So 1 upon 2 factorial 2 factorial. So 1 upon 4 and x by 2 to the power 4 and plus dash dash dash. This is the infinite series that is known as J0. This is one of the previous year question. First sec minus and then plus. 0, 1 and 2. So we can write this as 2 factorial square and then 3 factorial square. Similar terms will come. Okay. Now let me write J1. Write J1. So what will be the first term?
X by 2.
X by 2. Correct. What will be the second term? So if I take this x by 2 common in J1, I will get 1 minus 1 upon 1 factorial 2 factorial x by 2 square plus 1 upon 2 factorial 3 factorial x by 2 to the power 3 minus dash dash dash, like this. So here 2 and here 4. एक बार देखना जरा. Put the value here, j1. So I mean first term will be x by 2. Second term will be minus 1 by 1 factorial 2 factorial x by 2 cube. Third value will be plus 1 by 2 factorial 3 factorial x by 2 to the power 5, like that. Dash dash dash. Clear है भाई सबको? It is coming.
Yes, sir.
Try to put it and get this, everybody. Now I am removing this part. सबका आ गया रखने पे? Yes.
Yes, sir.
So please see this. Now if I plot this J0 and J1, so J0 is like this. This is J0 with respect to x. The value of J1 is like this. This is J1. The value of J2 is like this. This is the value of J2. So this is the axis J and X, and this is the X, and these are the values. Can you see that distinctly? So the value of J0 you can see only even powers are there. So this is even function. If you plot it this side, it will be symmetric. And the value of J1, all other values will start from 0. Only J0 will have value equal to 1 at 0, correct? And all other terms will be slightly right shifted in the maxima, like its maxima is here and its maxima is here, shifting right, its maxima is here, shifting right, like that. And the value will continuously decrease also, like here it is 1, it is less than 1, it is much less than 1. Okay, so this is the property of these three polynomials J0, J1 and J2, which you should take care. These properties are very important. Questions have been asked in your previous exams on this. Any doubt? Otherwise we can't plot it, na? It is so complicated, we can't plot it. So we have to just remember
Sir?
it. Huh.
Sir, you have also written in the solution j minus n of x.
Yes.
Sir, you have also written in the solution j minus n of x. C
Huh.
to j minus n.
So
So, sir, what about that? How we will do this j minus n?
So just n is replaced by minus n.
So okay.
No other change will be there. So j of n and j of minus n is just a difference of negative sign. Okay, so just take care of this jn, and jn I will tell you the relation between jn and j minus n. So there is a parity relation in that. So if you want to see the relation between Jn and J minus n, so that is only minus 1 to the power n. Okay. So if you know one, you know another. Now one very important property is that the value of J1x is equal to minus J0 dash x. So if you know J0, just take a derivative of this, differentiate J0 and take one negative sign, you will get the value of J1. This is very important property. J1x is equal to minus J0 dash x. And two values are very popular in this. पहले इतना लिख लो, इतना सबने नोट कर लिया? Have you noted it down this much? I want to tell some more polynomials, some more Bessel's polynomials. So not a lot of things can be done in exam. So that's why these basic questions are asked, because they know that if you make a question, it will become very, very lengthy. So they know that it is objective type question. Huh? So that's why they ask these things which we know already. Now, if you put the value n is equal to half, not an integer, then this j of half x is equal to under root 2 by pi x into sine x. And if you write j of minus half x, then this series results into under root of 2 by pi x cos x. So because you see they are so easy to notice, so that's why I am telling you. And two more things, that cos and sine can also be written in the form of Bessel's polynomial. So cos, because it is even function, so it is written in the form of j0x plus 2 times summation n is equal to 1 to infinity minus 1 to the power n j2n. See, it is written in the form of even polynomials. And sine being odd function, it is written in the form of odd polynomials. 2 times summation n is equal to 1 to infinity minus 1 to the power n plus 1 and j 2n plus 1 x. So these three are very, very important properties. एक बार जरा ध्यान से देख लो. All other things are very, very difficult. So it will not be easy to, give questions on that and solve questions on that. So we have to concise ourselves up to this, because whatever properties and whatever things we discuss, that should amount to some objective type question. Otherwise there is no point of studying that for this particular exam. बात समझ आ रही है ना? So this is what all I wanted to tell you about the Bessel's differential equation and Bessel's polynomial. So you also don't go in much detail. Whatever I have just taught you, just to focus on that. This now write in brackets that this cos x is even, so even polynomials are used, and sin x is odd, so this j2n plus 1, that means odd polynomial is used. So now let me start another differential equation, another special function, and that is Hermite differential equation. Hermite differential equation. So this is very special differential equation that appears in quantum mechanics. So right here they appear while solving Schrodinger equation, while solving Schrodinger equation in quantum mechanics for harmonic oscillator problem. For harmonic oscillator problem. So what is harmonic oscillator potential? You know that is half of kr square. This kind of potential. When we put it, when you put this type of potential in the Schrodinger equation, so you know here we will discuss in some detail because you know this is little easy than Bessel's. So question can be asked. So what is the generating function for this? Generating function for this Hermite. So the generating function which is given in the question, many times they have asked in exam. So this is already given that g of x comma t is equal to e to the power minus t square plus 2tx, okay, is equal to summation n is equal to 0 to infinity hnx and t to the power n by n factorial. So by comparing t to the power n on both sides, right, by comparing powers of t on coefficients of t, sorry, by comparing coefficients of different powers of t, different powers of t on both sides, okay, on both sides. So you can see here it is exponential, so you can open it and then here you have t to the power n and you have to compare the t to the power n on both sides, and what you will get as a coefficient will be the Hermite polynomials. So the value of h0x will be equal to 1. इसको खोल लोगे ना, because we know e to the power x, that is 1 plus x by 1 factorial plus x square by 2 factorial plus dash dash dash. We know this, so we can open this by taking this whole quantity as x, okay, and then you will get different powers of t, and here you can open it h0 t to the power 0 by 0 factorial plus h1 t to the power 1 by 1 factorial plus dash dash dash. Then compare the coefficients of t, okay. So this will be h1x will be equal to 2x. I again suggest you to remember 2 or 3 polynomials. h2x is equal to 4x square minus 2 and h3x is equal to 8x cube minus 2x, okay. So like that you have different polynomials. I can give you h4 also. So the value of h4x will be equal to 16 x to the power 4 minus 48 x square plus 12. So these are some polynomials of Hermite. So now the questions that has been asked on the Hermite polynomial is about the special values. For example, what is value at 0? Okay, so let us discuss that. Some special values of Hermite polynomial. So what they give? They give question like this: 8x cube minus 12x. Okay, so you all keep Erfkin soft copy to see any. If you want to see these things, you can see it from this. So let us calculate the special values. And the question was asked on this special values. Special values. So for example, two special values are very important. The first one is h of 2n plus 1 0. The odd term, see, for example h1, at 0 it will become
0.
0. So like this is a previous year question, that what is value of h50? What is the answer? 0. So suppose I give you a question that generating function of a polynomial is given by this, and you will immediately recognize it is Hermite. And then they ask what is the value of s7. So you don't know what is the value of s7x, but you know the value at 0. So what will be s7x? h70? 0, correct? And the value at even h2 and 0, this will be equal to minus 1 to the power n 2n factorial upon n factorial. Minus 1 to the power n 2n factorial upon n factorial. This is the value at x is equal to 0 for even one. So let us calculate this also. Like I want to calculate 0, h00. So that means what is the value of n here? 0. So what I will get? 1. So you see, at x is equal to 0, it is 1. So now calculate this one, h2. So you will get minus 2. So calculate h20. That means n is equal to 1. So you will get minus from here, minus 1 into n is equal to 1, 2 factorial by 1 factorial. So it will be minus 2. Correct? So this is clear. Special values, even and odd.
Yes, sir.
Even and odd values is clear. So about Hermite polynomial, this is very important to get even and odd values. Okay. So next thing is the parity relation. That is also very straightforward. The parity relation. So suppose I have hn of minus x. So that will be equal to minus 1 to the power n hn of x. So any polynomial with minus can be calculated using this parity relation, hn of x. So actually we write it like this: hn of x is equal to hn of minus x, like this. So let us calculate using this. Suppose I want hn of, suppose I want h2 of minus x. So it will be minus 1 to the power 2 h2x, correct? which is equal to h2x. So in h2 if you replace x by minus x, nothing will change. सही है ना? So this is the parity relation. So we will discuss other properties in next class, and then the last one we will discuss, which is Laguerre polynomial. And keep it short, keep it simple. जितना मैं करा रहा हूँ बस उसी के आसपास आपको देखना है, उतना ही टाइम आपके पास है इस चैप्टर के लिए. ओके, चलो, थैंक यू सो मच.
Thank you, sir.